Today's lesson is on SOL 7-6, which is our similar and congruent figures SOL. So the first thing we want to review is what congruent means. And if you remember, congruent polygons, that just means congruent shapes, have the same shape and the same size. They're literally identical. If I were to draw things over here, I would have to make them exactly the same. Which I didn't do that perfect, but they should be. Congruent means you have the same shape and the same size. Whereas similar polygons or similar shapes have the same shape but are different, but their size is different. And this would be like if I had one large triangle and then I had one that looked exactly the same, it was just smaller. So congruent have the same shape and size, whereas similar polygons have the same shape, but their size is different. And now, so the first thing we have to be able to do is to review how to tell are two shapes similar. People look at it and say, oh yes, of course they are. But can you actually prove it mathematically that these two shapes are similar? So there's 3 steps to follow. The first one is find one pair of corresponding sides, and write them as a proportion. Now corresponding just means they're in the same spot on both things, and I'm going to mark those using like the same shape or the same color. Like I know these two are corresponding. They're in the same shape, just on different polygons, or on the same side. So we have 15 over 5. I'm going to make a proportion. It does not matter if it's an improper fraction, because in the end it's not going to make a difference. Step 2 is find the other set of corresponding sides and write them as a proportion. So I would see that the 5 and the 3. Now, because the 15 and the 5 are on the same shape, I need to make sure that the 15 and 5 are the same here. And then since this little 5 and little 3, I'm going to make sure they're next to each other. So then I would cross multiply. You guys know I like my colored pens. So I would literally do 5 times 5 is 25. And 15 times 3 is 45. So these are not similar. They looked like it here when I just glanced at them, but when I mathematically went to prove it, my math proved that they are not similar. Had these numbers been the same, they would have been similar shapes. Now sometimes we aren't even given the actual figure. We're just given information. And we have to be able to line up and tell that things are similar. And I know I always tell my students, if you're given the information, draw the figure. So it showed me that there's a triangle, and I know it's triangle ABC. So I'm going to literally label A, B, C. Now it says this little symbol means similar to triangle DEF. Now, since the A was the first thing and D is the first, my A and my D have to go in the same spot. Since B is in the same spot as E, they have to go together. And since C and F are next to each other, they go together. So we can just make note that they sometimes go together, or that we have to draw them rather. Now sometimes you might need to rotate your similar figures to make it easier. These two are similar, but they don't look like it. You would have to physically rotate it. And I know for me, to rotate it, I have to be able to draw it back out. So I kind of take this shape and I mentally turn it, and then I draw it. Now in similar shapes, the angles are the same. So once I turn this, we show that the angles are the same using little curved lines. So I would put like one curved line here and one here to show that they match up together. I will put 2 in this corner and 2 in this one to show that they are the same. I could put 3, and then I could do 4. So each one has a different number to show which one it matches up to. And then when we get to congruent, the traditional notation for marking congruent angles is the curves. And to marking sides, if we had 2 shapes that were congruent, and I wanted to mark it, I could literally put what we call tick marks on them to show that they are all 4 the same. And over here I could do the same thing to show that these are the same as those. And then the last thing that we learned with our similar figures was how to find the missing part. So finding the missing measurement. And to do that, we find the corresponding sides. We set up the proportions, and then we're going to multiply. So I'm going to use my same color coordinating. So I'm going to use my information from A to B is 16. Well, this doesn't even look the same. So my first thing I'm going to do is I'm going to redraw this so that it at least looks the same, so that my short side's on top. I'm going to relabel. I know that the A, since it was first, should be in the same place as the W. The B is up here, needs to be in the same place as the X. C and Y need to go together, and D and Z. And then I can relabel. I see that from X to Y is 2, so I'm going to label that. And from W to Z is M. That just makes it, not everyone needs to do that, but if you're visually it's hard to see, then please rotate them. So 16 centimeters matches up with our M, so I'm going to put 16 in M is equal to, and then my 8 is the same as my 2, so the 8 goes on top since I started with figure, and then my 2. And now I'm ready to cross multiply and divide by the dot, divide by that other number. So I get 16 times 2 gives me 32. 32 divided by 8 equals 4. So my missing part would be 4 centimeters. You are now ready to go ahead and do your practice.